of a mnemonics.
Alright guys, let's get started without talking too much about Fahrenheit scale. Because we can't fix the world's problems. Although some of the API requests are getting close to it.
We're now live.
We are live. Unfortunately, Carol is not here, so I get to decide which issues I review because nobody's yelling at me with an issue number.
The most interesting ones.
Are there any by me?
Name references? This is great, we're down to 8.
How many of them?
Wow, that's all? We need to find more.
The bottom one we looked at last time.
Yeah, let's not look at the input.
Let's shoot for finishing all of them today.
How can it be both ready and blocked?
It's something.
Yeah, don't start with the int pointer. It's gonna be hard.
Right.
Oh.
Why is the int pointer hard?
It's because it's blocked on the language feature. We're deciding we're going to wait until we're consistent with what native ints are.
So then is it still ready for
They had this interesting table.
Take ready for review.
Yeah. Let's do that. Well, I guess it's marked with block. It kind of works for me too.
Whatever.
Same thing here. What is this block done, Crystal?
What is this one?
transformation status?
Yeah.
Oh.
It was originally blocked because we're going to wait until we start reviewing the other APIs that we're going to return this enum and try to get a consistent feel for what we want.
Yes. I think Ari it's in his PR, so it was just renamed to
So we just mark this then as approved and move on? Like
let's. I propose that we. I wonder, like, it was not in the one of the reviews of the actual APIs. Like, why are we reviewing it independent from everything else?
Originally, Stephen filed this because when he was adding the span APIs, some of them, we asked him to return this for some of the APIs, the Triage APIs. And then we were like, well, let's just track this until we get the rest of the corefxlab APIs that are using this, and then look at it holistically, decide what we want this to look like.
Didn't they come in as part of the basics for review?
That's what I thought.
Is that the only ones, or are there others? I don't know.
What do you mean? Other enums?
No, are there other APIs that are using this enum other than the
yes.
encoding?
Base 64. What was the other one that Ason was doing? Binary doesn't use it.
Text encodings probably do.
But they are doing now parsing and formatting, which don't use it because it's only like when you have like large buffers and like transformations of bytes.
I felt like we were gonna
So maybe it's only the basics.
and decide if we're going to kill the enum or not.
Yeah, but it's part of the base 64 PR. In fact, that one is not on PR; it's checked in.
So we can
Probably just shipped yet though.
on the enum.
I think we should look at this, as part of the follow-up of this, is look at some of the APIs that we exposed it on. And this. And you and Jeremy had strong opinions about potentially getting rid of the enum. Just going straight with Triage.
Yeah, well, so Levi initially had some objections, and then he kind of, last meeting he said that he conceded. After looking at, with us at the API, so
I don't have a strong opinion personally.
in general, I find it weird that it says, it's still open because it is a dependency of an API that we already approved.
Well, when Stephen did his APIs, it was CHX.
Yeah, I'm not surprised that it was opened initially. I'm surprised that it's still open. I don't think we should be reviewing it.
I was about to say, like, I don't think...
Are the values correct? The enum values in the name isn't even matching this name anymore, is it?
Yeah, it's probably...
I also don't think you can review an enum without actually having consuming it. I mean, that is...
Right, so...
Which is what this was blocked on.
So...
Yeah, click on the base 64...
Okay, let me just say, this is no track.
Yeah, it's actually merged. We can even look how the enum looks. Let's check it. If we are interested.
I want to look at what the final thing looks like. Can you look at the right there at the bottom?
Oh, let me just do this.
Just hold on. So it became operation status with values done, destination too small, need more data, and invalid data.
Okay.
Well, now we can't see what it used to look like.
It was actually the same except for the different name. It was transformation status.
Yeah. All right. Move on. Let's move on.
Yeah.
Okay.
Just in time.
Exactly. How did you know that? I literally just pulled this up.
Oh.
You have to work on your entrance effect, though. You have to make a David Keane entrance. You just kick over the door and say, "The view can now start. I'm in."
What is this one? This type is already checked in.
Yeah, so there's two questions, right? The first one is, should we add the bulk operators that we have on span, like fill, clear, copy to, and index off, etc. Second is, we want to discuss when to use span and when to use a property. Method versus property for span to memory conversion, span to memory conversions.
Yeah, I see.
Those are the two.
So I can tell you my opinion on the operations. I'm kind of torn. I understand that it would be convenient to have these operations, but they are potentially a performance trap, in the sense that calling these operations on memory can be expensive. The better way to do it is to get a span and then call operations on the span. So let's say you call several of these operations in one stack frame. It's better to get a span. If you call just one, they are pretty much equivalent. But
is there any benefit to, if you're just going to call it one, is there any benefit to, like, can we do anything better in these implementations than a caller could do by calling span.copy2?
I don't think so.
They're essentially convenience methods to avoid that.
Yeah, exactly. They are just convenience methods to get a span and call them. Well, even if you do like multiple of these calls, they will be getting multiple spans, which is equivalent to you. Anyway, I think we understand. Like these implementations of these methods would just call span dot index of.
So then there's no harm in them being.
Well, there's a harm that they kind of, a better way is to get a span, have a local variable, and then keep calling different methods on the span, not on memory.
Also, some overloads missing, so there's sequence equal for memory read-only and read-only read-only. Should there be memory?
No, because the reason we have read-only memory and memory is so the extension methods can be called.
Okay.
The second parameter, it can be just cast.
Right.
Personally, I mean, I don't have a strong opinion. My inclination would be to just leave them on span, and you just do .span if you want to access them.
Yeah, I think so too. Otherwise, honestly, the worst possible world is when you have like two types that you basically have to manually keep in sync. I think that's not great.
Yeah, that's another negative of adding these methods, is that we will forever have to, like, whenever we add to one, we have to add to the other, or they get, they diverge.
Do we have any other duplicated members right now in memory? Can we bring up what's in memory?
This one here?
No, that's just a spoiler. Just click that. Yeah. These are the APIs right now.
Hello, Steven again.
So slice is common.
Well, slice is not different. Calling that span, that slice.
Oh, sure. Yeah.
But
he was asking for duplicate.
No, yeah, I'm trying to understand if we've already got some APIs where we're duplicating.
Yeah, that's a good question. So I think
toArray is probably one of the only ones like that exists on both memory and span, and there's no difference, right?
Correct.
Yeah. What about the mutation ones? If you get this calls not span here, you're not mutating the memory, are you? In place, are you?
Well, if you the span type or the memory type themselves, they are immutable, but the contents that they point to is not.
So if I call memory of t.span and I write to that span, it's going to basically reflect back and it's sharing the same.
Yeah. Okay. So I think Steve is right, or whoever said that. ToMemory is the only one.
ToArray?
ToArray. That, like, just calling span that ToArray would be equivalent.
I mean, honestly, those seem fine. And the reason I say that is because I think of those essentially as just
Another type of conversion.
yes, and I think like having them on the actual type makes sense. But
Okay, I buy that.
everything else is just I mean, even the slicing one you could argue is somewhat redundant, but like
No, slicing is very not redundant. Because if you call span that slice, you're gonna get span, which you cannot store on the heap.
and you can't do it yourself, right? You can't do
You
slice
cannot
and then
convert back from span to memory. Exactly.
Does span already have fill and clear, for example? So if you do memory.span.clear, it'll clear this.
Yeah.
Okay.
Okay, so let's look at those. So the only ones I'm thinking. So what is as mem? Oh, I see. Yeah. So maybe the principle is if they are conversions, we keep them or add them. If they are not conversions, we don't. So conversions are as memory from an array segment, as read-only memory.
Do we really want those to be extensions? Like, so every array has an as memory on it?
Yeah, that's a good point. I don't think so, actually.
Every array has an as span, right?
Oh, well, that one, I don't know. I like span more than memory, so maybe I'm biased. I don't know. What do other people think?
so honestly, like if we have .span, it makes sense to me to have .sMemory. Because I mean, like as we said before, like we think of these types as effectively the same thing, except one of them allows you to put shit on the heap, right? And it's as a result, it has slightly more overhead, right?
It's just we have like, having one as span on array. It's additional member on array. Having two, and then people having to think which one they want.
Well, it looks like it's up more than two. There's as memory and as read-only memory plus the as span.
It's actually is 4. So like.
So one could argue that what we want is to get rid of as span to add memory, and then you can do as memory.span. Or you can call the span constructor. I mean, unless you think that memory is going to be more rare.
So the reason I think it's useful to have them as peers is like think of the scenario where somebody has to pass them around, right, and then have to call an API on it. That does it only takes memory or takes span.
It's just I'm thinking. So I don't have a strong opinion, but in the code that I wrote, I very often I had an array and I needed to get a span because then I can do like some operations on arrays that you cannot do natively on arrays. Creating memory is something that like you do once and somebody just passes you the memory and you cache it and store it. It is basically a type to store something for later, which you don't do very often. You don't do it like in every single routine that, you enter a routine, you have an array and you do some operations on it. You don't cast local arrays to memory.
Well, I mean, often it's
So that forces you to type new, right? Which, at least for C++ people, indicates it's going on the heap.
So for what it's worth, I have been
It doesn't.
testing,
So
like,
memory doesn't, like if you do new memory, and pass an array, no heap allocation is happening.
Okay.
so I have, and like with some of the APIs we've added that take a memory and say a cancellation token or something, I have given an array, I have passed in the array, but I'm not calling as memory or the equivalent explicitly. I'm just letting the implicit cast happen.
Oh, because of an implicit conversion from array to memory?
Yeah, if you don't call any method, you just want to convert, then there's a cast.
So if array goes implicitly to both, does that mean that we need to be careful of having overloads that take memory and span? Yes, we do.
Well, in fact, it probably doesn't make a lot of sense to have both. If you need to store the thing for later, it should take memory. If you don't, then it should take span.
I think the implicit cast for F#, if there's an issue with saying that we should have explicit methods for every implicit cast. Because otherwise,
doesn't want implicit conversion?
they have to have a specified like opt implicit. And somewhere below, somebody commented with the code sample of what it would look like. That's.
Yeah, I'm not against providing explicit methods for implicit operators, but I don't know that they have to show up in everyone's face as extension methods.
No, I mean I agree with that in principle, but I find it weird if you do it for half the types. I think honestly, like, I don't think span is more important than memory. Memory is more important than span. If we do it for one of them, we should do it for both of them, or we should do it for neither of them. I mean,
but I'm saying that there are many scenarios where you want to kind of cast, in quotes, cast array to a span and then call methods. And for memory, it's quite rare. For the reason that we were just discussing, you don't call methods on memory. You shouldn't be doing this. You should call them on span because they are more efficient. So usually, like in a local routine, when you have an array, you don't cast it to memory and then start calling methods.
So what kind of methods are you calling on that guy?
Like
async methods? Async methods would require memory, right?
Well, but you pass them. You don't you don't get an array into an async method and pass it to memory and then start calling methods on memory. It doesn't make any sense.
Aston, can I also ask you? You mentioned some rule around equivalent operations for implicit casts, but don't we already have one in Span's constructor?
And memories.
Which one?
The constructor.
Constructor has implicit cast?
Well,
no, I'm saying there is a constructor for span that takes an array, and it's exactly the same as what the implicit cast does.
The as memory extension method is the same as new memory of array.
Yeah. What's the question?
So he's basically saying like the rule
How is that deficient?
I'm sure we already have a replacement for the implicit cast. Instead of doing OP_implicit, they could just new up the span.
Correct.
Or memory.
Not for array segment.
Yeah, they can. They new up a span and they have to pass 3 parameters: array segment dot array dot offset dot length.
Isn't there a constructor that just takes the array? Why can't that one be used?
Well, if you have the array segment of t, but then that would just argue that we should just add a constructor that's array segment of t.
Sure, if you have the array segment A, you can pass the 3 arguments.
I mean, what is true? As soon as you have a generic, like a conversion method, is nicer because they don't have to say the type again. But yeah, I don't know how that works in F#. Also, you don't have to say the type anyway because they infer it or something.
I mean, honestly, I would almost prefer to remove as span than to add as memory, as read-only memory, and whatever else to array and array segment.
I'm willing to believe Christoph's belief that memory will be relatively rare and span will be relatively common, and therefore we're adding span because it's relatively.
So to me, my argument is not that one is rarer than the other. Calling methods on memory is rarer, for the reason that the better way to call methods on memory is to get a span out of it. It's a factory for spans. Therefore, why would you first create a factory and then get a span out of it if you can just get a span in the first place?
We're talking about the as memory ones, though, right?
Correct. So
the case where you hit that all the time is you're calling a method, of which there will be more and more, that accept a memory, and you have an array.
Yeah, you can just pass an array to a method that accepts memory. You don't need to call as memory.
Unless you're just trying to give them half of it. You want call the constructor, call as memory.slice.
But Chris, if I can do the same thing with span, if I have a method that takes a span and I have an array, I can just pass the array. So what's the benefit to ask span as memory?
So for calling methods that take parameters, I agree with you. What I'm saying is very often there are 2 different groups of scenarios. One group is what you mentioned. You would have an array and you just want to call a method that accepts either array or memory. Yes, both of them work the same and we don't need any APIs, we have casts. There's a second group of scenarios, which is you have an array, you want to wrap it in something and then call methods that don't exist on array. And either don't exist or whatever it is. And
I agree with you, that's a scenario. In my experience thus far, it's very rare for me to use either the span constructor or as span that just takes the single array. Most often in the cases where I'm going from the array to the span, I also have the offset and count I want to use, and so I'm forced to use the constructor today because there is no as span that takes.
No, but what you would do is you do as span and slice.
Yeah, exactly.
Yeah, and that's why I argued at a previous meeting that we should add, if we're going to keep the as span, we should add an overload to it that takes the offset and the link.
As span and slice is more expensive than just using the span constructor.
You'll bounce check twice.
And there's multiple temporaries which we've already seen are hurting us with the JIT zeroing.
So I thought we've done like the experiments 5 times over, and it's not true that they are more expensive. By the way, I was arguing that we should not use first span and then slice, and Jan keeps saying that they are equivalent in performance, whether we have one method or two, and then we do experiments, and Jan is right. Our JIT does pretty good job noticing that you do stupid things twice in a row and then just get rid of one of them.
Let's talk about some high-level thing first, because I think that, to me, I agree with the principle of not putting extension methods on types, but especially general purpose types, but in this feature area, I'm not convinced this actually would be bad to begin with. I mean, if we feel it's super controversial, we can just punt the extension methods for now and see where we land and then add them later, but as a principle, it strikes me as arrays, people don't call methods on arrays that much, so it's not like you dot into something and then you're surprised what you see there. And it seems logically arrays and span and memory, they're all related. They're more or less the same feature. They're all types of the same thing. People that use arrays today, maybe they should use span and memory depending on what they do. I mean, they seem related versus some of the stuff we talked about here, like extension methods on string, for example, getting span of bytes out of the string. That one I would see more of a problem. But in this case, it seems like array is substantially low-level enough and related enough that I don't think it would be a problem if we added there. I'm just generally hesitant to do almost a probabilistic approach, where we say, half the APIs are on, the other half are not. That seems the reason I don't like it is because it makes it harder for somebody to learn the feature and explore the feature. If it's just based on, I do this API more frequently than the other APIs, fine. But it's still how do you reason about the feature area? Do you think of these as peers? And if so, that the API should also appear as peers in the API service.
So I agree with you. This is the main negative of not having these methods. We have 3 choices, right? We have one choice. We just add these methods. We have them both on to cast to span and to cast to array.
Right.
We have a choice of just leave it as is, meaning there are methods to cast to span but not to memory.
Right.
And then we have a choice of removing these from span.
Right.
I'm really not a fan of the latter, because unless we do what Jeremy is proposing, which we don't have a cast to span, we have a slice on array, but we've been there, we changed our mind on it. Unwinding it now would be hard because the pattern of calling first you have to cast before you can slice. We decided this is the pattern that we want. And there are many APIs that work like this.
Yes, I think the pattern I would not agree because I think the argument was pretty sound to follow that pattern.
I'm not saying add slice method, right? I'm saying add extra 2 parameters to as memory and as span.
I think the point was to make you familiar with the concept of slicing. And since slice is free, this is the right approach. Whenever you want, you slice.
Maybe, but I find it extremely annoying. The only time I'm ever calling as span is so I can immediately follow it with the word slice because I'm trying to give half my array. So I want to just say as span 0, how much you want to. The fact that I'm writing slice again means I'm probably going to, in my project, start just adding an extension method as span takes the count so I can get rid of the extra 5 characters.
So I think that we do have a bit of a problem. The code is very busy. I agree with Jeremy. When I write code, it's exactly the same. It's always as span slice. And then you're trying to read, you want code to, when you read code to just have information about the logic, what the code is doing, not a bunch of planning that you copy and paste.
You would store that in a local, right? If you're slicing over and over again, or if you're taking a span inside a argument as an argument, that would be a local method that you would slice once, or yet you would get the span once. You're not going to do as span slice over and over again. That might be as span will be called once.
Correct. Well, no. Usually, I think the most common pattern is as span slice, and then you keep slicing the thing that you got from the first.
So even then, it's just only one time.
Yeah, but still, the code kind of looks a bit too busy. So I think it's a problem now. I don't know whether the fix is to just add arguments to as memory, but maybe. Anyway, so those are the 3 options that we have. I would.
Our minds up on that one. As I said, I'm more concerned with consistency between the two. I think having irregular exposure is worse. I would say let's either add them for both or let's remove them for both. Like, I mean,
Yeah. So I don't like removing the ones from span. The other two options I'm okay with either. I would slightly still, I think, prefer not to add the one to custom memory, because I think the scenarios are almost non-existent, but I don't mind. I think Steve, you kind of implied that it's over your dead body that we had 8 cast methods to array.
No, not over my dead body. That's extreme. I don't want to I don't like cluttering up core types like that. What namespace is memory extensions in?
System.
System, yeah.
You get it by default, all those methods.
Yeah, I
mean, all those is also stretch, right? We already killed half of them, right? Like, we decided to do those.
Well, those, I don't care about ones on memory or read-only memory as much. I'm concerned more about the ones on array. If I have an array and I dot into it and I see a bunch more stuff, but whatever.
I think copy 2 seems fine because it's an overload. You don't actually add a new member. So the actual new member is as memory and as read-only memory are the only two members.
But the copy 2, all the other ones we are not adding, correct? We said
putting sequence equal.
You want to get span first and then call it.
Is there really an advantage of doing that for the index though? I guess you're still going to always get the span no matter what. So it's not about them doing that. They do it.
I think for index of, like, this is not a conversion, right? So, like, I would say
memory is
it's
not
the same bulk as any other method.
Multi-slice back thing, right?
What's
memory is still contiguous?
Yes.
Because I know that there was the other thing, the disjoint memory object.
For my information, I know it's a little orthogonal, but is memory of T exactly the same as the span, the slow span, essentially?
No.
They are different?
Yeah.
There's memory still some checks to make sure you can't put it on the heap for the slow span verification.
Well, memory can be on the heap.
I know memory can, but
slow span. Well, the compiler checks does the checks. We have a bit of a we do have a bit of a problem, but it's unrelated to this review.
That's right.
That you can put slow span on the heap.
That's right.
If you do some really clever coding that I will not.
So that's the difference between slow span.
While being recorded, tell people how.
All right. So which one do we want to remove? So, like we said, like we would remove fill and clear. There.
Oh, yeah.
We would.
Copy 2 feels a lot like a conversion to me in some ways.
And copy 2 I can see. On the other hand, though, copy 2 is like you are ending an operation, you're not starting one, right?
Yeah.
You're already done with it, essentially, at that point. So that's why I don't know. Copy 2 I could go without.
Yeah, these are fine, maybe.
I mean, but isn't it just going to say span.copy2?
True.
I mean, I thought that you were trying to reduce that.
If you do span.copy2, how did you get the memory to it back out from that? You have to pass it into the constructor, or are you going to?
Well, so you have a memory, and you're trying to copy it to another memory. Yeah. So it would be
span.copy2. Talking about clutter before, like that, I've seen that in a lot of tensor places where just copy 2 and then just copy 2 there.
So yes, I mean we could say that this one is that we're doing it because it's compacting and allowing it to be more expressive.
I mean, so many of those would be compacting. I would say, like, one of the principles that somebody proposed is that if it's a conversion in a broad meaning of the word, then it's fine, otherwise it's not. Because you have many of these types, and like depending on your scenario, you want to kind of move data between them. Once you like start doing like something with the data, like the index of and sequence and so on, you should be using span. That could be the principle.
Yeah, but say if you do something with the whole thing, that seems fine, right? Which is conversion and copy 2 are both like universal things, right? Versus the other ones are literally messing with individual elements.
Well, sequence, yeah, maybe.
I mean,
Copy
sequence equal
to
is one of those things where it's like, well, do we want this or not? But like, I think sequence equal is probably in practice rare enough that going with span.sequence equal probably wouldn't be too bad.
Do we add this because of F# too? I know that they specifically look for sequence equals for their conversion things.
Well, how would you call it in C#? I mean, we don't have overloaded double equals to it quite.
I'm just saying, I know the language, the F# language uses these sequence equals in some of the cases. So.
The language like compiles code into sequence equal calls.
They use they were using the interface. I remember we had to add some of those methods for tuple in order to.
I think you talk about structurally equatable, right?
Yeah.
Which is different from this. Yeah, that's a different one. Okay, so like this one we already agreed we want to remove, so this one is easy. So what about sequence equal then?
Let's remove it.
I think it's probably rare enough. Honestly, I could live with that set. That seems sound to me.
So one additional thing that I would do, if we keep the methods, and it will also highlight the benefit of just not having them at all. I don't think we want two extensions types for both span and memory. They are close enough. We should put everything on span extensions.
Yep.
And pretend that memory is a kind of span.
Can we?
Yes.
They're always shipping it together.
Is it like the complicated oob/not oob frozen?
So like span and memory, we already said that they are one feature.
They are the one feature.
Span extensions is not locked just yet.
What would be the benefit
That
of
was my question. Is the span extensions class itself in a bad state?
What's the benefit of doing that? The memory extensions, that type is never really seen.
There's some kind of magic types in system namespace that nobody ever uses, because the only thing that they are using is extension methods that appear as instance methods on these types.
So it makes the IL so small.
Like from a C# language perspective, extension method holder classes could be like hidden, correct?
Well, I mean, like merging them also has the benefit of if we're going to add things to them in parallel, like you're not like they're together. You edit the one file to do both things instead of always be editing two files, and you're always looking like, oh, did you do the other one?
Well, to me, the pragmatic benefit is also that you see them logically as overloads. Right, so you see the type. Like if you're in separate types, you kind of have to like do the combination in your head.
Yeah, who sees them? Not the developer. Only us would see them as ledger.
Yeah, that's what I meant.
Yeah, but that is a benefit, right? Because I mean, like when you design new features, you're basically forced to think of them as equals.
Or we can just like remove all these methods and don't have this problem.
Yeah, but you were the one saying you don't want to get rid of some of
Well,
them.
no, so if we're getting rid of method, why would we keep memory copy to memory but get rid of array copy to memory? Because an array is a memory and is a span. And so if we're...
It's fine. I think copy to emo said it will show up as an overload. It doesn't have like as much overhead.
I'm asking on memory of T and read-only memory of T. Like you can drop to the span.
But he's saying you still have to type for that guy, right? So you have to put it somewhere. So if you don't solve the problem, you're
no, but I'm going back to his previous principle of like just grab the span, stop talking about memory as if it's a thing.
Sure. So you're saying if we would kill that one as well, then...
And then I'd kill the instance members too. Like essentially, Christoph's earlier argument is delete this entire, or delete everything on the screen because it's just faster to go through the span, or at least it's more informative to go through the span. Now the other argument is C# is a very descriptive instead of cluttered language, and so are these worth being Are these descriptive enough to be worth adding the extra code?
Yeah. So who filed the issue? What motivates adding these members?
The bulk APIs were added because of wanting to have parity between span and memory. I think Emo in our previous discussion mentioned that we should treat both of them the same. These ones were just for completion, that all other APIs that we have in span should exist in memory as well. And the as memory ones were for F#, like explicit operations for implicit. So copy to and sequence equal, etc. were all be bucketed in the same reason, which is rarity with span APIs. Like for example, somebody mentioned how do I copy from memory to an array, to another memory, and because they couldn't exceed the APIs, the solution was get a span, you can do it. So maybe that's a learning curve, but they weren't sure how to do that, and they wanted to do that.
Yeah, like I'm personally fine with we always make them look essentially the same. All that the memory ones do is say, internally it's drop to span and do the thing. That's fine. We just need a principle. And the principle of saying we're not going to have sequence equal because it's faster to go on the span says that we should delete all this.
What about this? So there's another one, which is if it's a conversion, then it's okay. Otherwise, it's not.
But Krishna's point is true, like about performance, like calling span again and then calling these methods is going to be faster because you're going to have it once. But for copy to and some of the other methods, you probably only do it once. So maybe it's okay to have those.
I mean, inlining, all that copy to memory is written as is span.copy to destination.span. That should lift that in the column.
No, that's not the negative performance negative. The negative is if you keep calling these methods in the same frame, the JIT of course will inline the inner call, but it will be calling getSpan multiple times, and getSpan is very expensive. Relatively, it's expensive to get a span out of memory.
So looking at like span extensions, if you just merge these members over there, it wouldn't look horrible. Like I mean, like the type is already pretty much a grab bag of things.
Yeah, it has string extensions as well.
Right. Well, okay. So what about this? We keep the copy to and try copy to on memory. As Steve mentioned, they are on memory, so that's like.
Yeah, they are not.
It's fine, and they are like conversions or like moving data around.
Yeah.
If we want to have copy to that extends array, I would just add it to span extensions. And then the as ReadOnlyMemory methods, can we confirm from F# team that they don't want to use the constructor?
I think I even opened an issue for it upcoming.
Well, the problem is like even in C#, the problem with constructors is you have to specify the type. Like, you don't get any sort of benefit from generic.
You have to say new memory uplight.
Which gets annoying very quickly because you write a ton of stuff. Versus if you say the .as, like it's very short. You don't
but just so you see, like I don't even remember any code that I wrote, and I needed this method.
Sure.
And Steve, who wrote a lot of code, probably even more code that uses memory of T than I did, also kind of doesn't like adding them and doesn't think that it's worth it.
Sure.
Also, it's a valid argument around the type T. That said, I would expect that 99.9% of code that's written uses these types. T is either int, char, or byte.
Sure. Like I'm not saying it's like a. Yep. It's just annoying to spell out because you have to have the brackets, you have to specify it, and like it's just not nearly as nice to type. But yeah. So okay, so that means we do this one, we repeat these guys, leave the other ones as is that fair?
Yep.
So we rename the extension class to like something more generic. Something more generic.
Oh, you think that we should rename the existing extensions?
Yeah. To not just span extensions?
You could call it buffer extensions, which would work.
Does anyone pay attention to the name of the extensions class?
No. But at least never visible in user code.
Well, it is visible, right? It's documented.
You can directly call it.
Sure. Yeah.
I mean, some that are invisible. I mean, it's not that you call code through it, but like IntelliSense and other things exposed to type names all the time.
The whole feature area is called span. That's my hand-wavy explanation.
Can you mark a class as editor invisible?
Is it though the assembly call system?
I have no idea.
So we call it memory extensions.
Mark an extension class is browsable false.
I would. That's actually not a crazy idea.
Yeah.
Hey, Emo, why doesn't the APIs of .NET show that any of those methods are extension methods?
Because I think the way I render it is I call Wes's stuff, and Wes doesn't do that. That would be my answer.
Alright.
Which may actually be not true, but like, I need to do the work to figure it out.
Okay, so
All the reference number is generated with this, so my code works.
heuristic of not adding something to memory is with something like sequence equal, you think somebody might call it 2 or 3 times in code, and therefore they should have snapped the span once to avoid the conversion multiple times.
Alright.
Is that going to break anybody?
So what's the name of the extension type?
Memory extensions.
So we're gonna rename the type called span extensions to memory extensions, but all the extensions are for span.
Oh, not all of them.
No, he said merge it with span extensions.
No,
Yeah.
we now merge span extensions into memory extensions since it's in system memory. That's the law.
It's a bit weird, but whatever.
There's T-array extensions, there's array segment extensions. There's at least one with memory now.
Okay, Emo is arguing that already some methods.
I bet money that as soon as we
You know
rename
what?
span extensions to something else, it's going to break something.
Probably because all the
Definitely will break some code.
like all the calls are to span extensions. Like you're calling it you're calling it as an instance method, but it's really a static call to span
It's
extension.
going to send me an email next week saying, why is this package update not working? And I'm going to be like, because you renamed span extensions.
It's fine. We should. I think.
That's what
So
I hear.
another reason to rename it is Steve has been asking for us to design extensions on spans of char, like other extension methods, and I think that memory extension kind of can contain lots of extension methods. I think we will be adding more and more extension methods, and it's good to have one type that is a grab bag for, similar extension methods. I am a bit concerned with some breaks that.
I would love to see your codification of that rule in another, framework design guidelines book.
Everything can be
Make one big grab bag type for all your extension methods that you'll ever add.
Everything can be rationalized after the fact.
Object extensions, that's where the party is. Yeah. Alright. OLAPs contains.
Well, it's in the wrong class.
Does overlaps?
Yeah. This one is so. I think we need these methods like this.
Yeah.
I just think that people want to know more complicated things than whether the
Because there are
things
4
overlap.
different things.
Actually, there's more than that. This guy listed all of the options. If you scroll down, these APIs cover all 6 scenarios, A to E.
I see.
So what does within do? Is it basic contains?
Contains, but I didn't like the name because it sometimes implies the contents are contained, not the span itself.
So is it
Oh, it's a pure range check.
that the
I see.
second
Just go to the table. There's a
second
table
to intersect first is second?
at the there's a table there.
But you have to call potentially. You have to call 2 APIs to be able to tell the cases.
No, they're 2 separate scenarios. One is with, let's say you have a buffer pool, you want to return it to the span back, the memory back to the buffer pool. You want to check if it's contained or within. The other one is for copying, etc. You want to check if it's overlapping. So they actually.
Let's say I want to know whether I'm in situation D. I have to call both overlap and within.
No. These scenarios can be inferred from either.
From either.
Right? No, overlaps is true. Means you're in B, C, D,
Exactly.
F, or F, G, or H. You then need to call within to figure out which one you're in. And also D and F got different letters, but they have the same truth value, so you can't tell which is which.
But the combination of overlaps and within is not unique. You have A and E and I and J are both return false.
Right.
So it's not. I'm not saying that it's not overlaps and within both don't have to be called for you to figure out what scenario you're in. Because even with this table alone, they're not sufficient.
Right. Well, I mean, what they're saying right now is that you do need to call both of them, and you need to call some other methods that don't exist.
Well,
if you need to care. Like, if F will destroy your model, you don't know if you're in F.
Sure, but like I mean, this sounds to me like a problem search of a solution because solution search of a problem because I mean, do we even know that you need to have this as an atomic operation? Like, how common are these scenarios? Right. Do we know that? Because I mean, honestly, I think like overlap seems. I can see that being very common. The other ones I would have to spend half an hour reading and to understand what the problem is to begin with.
So calling within allows checking for which buffer the given span is within.
Right, so I guess A, whatever A and the anti-A are irrelevant.
The anti-A.
Which might have been E. Well, A is this entire span exists in memory before that entire span, and I can't think of a time that that's useful to somebody who's not a hacker. So
we are all hackers.
I can't think of a time that's useful to somebody who's not trying to actively break your code. Simply knowing these have no impact on each other is. I mean, I guess maybe if you believe that they are subspans of the same buffer, kind of that's right. To compare.
So what is the order? Let's say we wanted a method that like gives you all this information atomically. Is there what would the design even be? Because maybe we have no alternative. Maybe this is the best we can do, and yes, you have to call it twice, and there are some limitations. What?
You would probably return a flex enum, and you would do like.
And the flex enum would have a table on MSDN that shows the A, B, C, D, F, G options.
Well, it depends on what the members are named, but like.
Well, I mean, I don't think it would be flags. I think that the A through J or whatever are separate states that you could describe.
You think? I mean, like, I would think that there's probably an indicator for how the start relates to the other start and how the end relates to the other end, right? So that's why I'm thinking of flags, but maybe that's not.
So that you can get it cited against it.
Well, they have the element offset. The element offset argument for that. Like how far into the first span is the other.
You know what? I have an idea. What about the following API? You pass two spans, and it returns you two ints that tell you the offset from between the begins and the ends.
I think that was one that was proposed by somebody else, whereas you have two ints instead of one. Two out parameters, you mean?
And they are ints. They are literally ints. So if it's 0, they are basically starts at the same location. If
or you call compare start.
If it's minus
10, which gives you one number.
Right. So what if? So you can definitely always do anything artificial that you feel like doing if they're based on pointers, which might get more into TL at you. And then if they're both if they're both backed by an array, but they're not backed by the same array, what are you going to answer?
What do you mean backed by array but not the same array? Then they cannot overlap.
So, right, so what are your ints? An exception?
No. No. So this is array 1.
Yeah.
This is array 2.
Right.
And it will compute the offset from this to this, and let's say it will be 1000.
So you're going to
and it will be offset from this to this, and let's say if the length of this one is 100 but of this one is 200, it will be 1100.
So you're going to drop the array to pointers and do that. Because I think that by the time that you're asking to compare, if they're both backed by managed arrays and they're not the same managed array, the answer is your question makes no sense.
Well, how does the current API deal with it?
False. It does not overlap. Yes. They're from different arrays.
No. Okay, if I see, if the reference...
I mean, these are moving around, right? So.
Yeah, and then GC compaction happens, and now the pointers are pointing in different places.
Well, you better not store them, right? You better just...
It's the sign.
Also, isn't the delta going to be larger than 8?
Yeah, it should be long to begin with.
Sure.
But like, yeah.
Yeah, so I don't know that we...
I'm saying this API would actually give you everything that you need.
It does.
What if you have a starts within and an ends within, and then overlaps is starts within but not ends within, or vice versa, and within is both? They just both give you balls.
I mean, having worked with lots, and they have text span, which is basically an offset in the length. determining whether one is overlapping with the other is trivial because you just have ints. But if you write the conditions, which is what you still have to write with these ints, you always have to stare at this like for like 30 seconds to a minute to determine, did I get the bounds correct? Because it's not intuitive. It's like, oh, star less than length, like it's, or less, like you read the condition and like it took me always 5 tries to get the overlaps and intersect correct.
But you see, so one thing we could do is, for example, just have overlap. It's very easy to understand. And then have this method for all the other cases.
Maybe. I don't know that we ever want to answer
because
that.
I think, so, also like it would be worth to talk about.
You have to have the method. I mean, like people could do it today.
Well, which method?
Like what you would do is basically trivial, right? You just extract the pointer and do the delta, right? Like how hard is that for the caller?
It is hard and it's unsafe code.
Oh, because you have to get the fuck, yeah.
So the reason, like one thing we should talk about is what the scenarios are. So overlap, like the moment you have 2 overlap spans and you want to move data between them, you need to be careful how you do it.
Right.
If they are not overlapping, then you kind of like, the code is, you can write naive code. The within, I wonder whether, like what the scenarios are.
But even then, like how many people have to write that code? Because wouldn't you just call copy?
Well, it depends what you do, because sometimes you kind of, we only have copy methods that copy like involved, but maybe you kind of want to like, poke at some indices and like move data between spans. And if they overlap, you need to be careful not to overwrite data.
Based off tests that I've done, buffer.blockCopy handles from A1 to any of A2 through 5. It completely handles like, oh, you're the exact same array in the exact same destination, I'm going to do no work.
Yeah.
And then it handles like, oh, you're copying into like 2 bytes to the left of you, I'm going to shift everything that way. And it handles, you're copying everything 2 bytes to the right, I'm going to handle that. So these 2 cases you definitely need to know, and then certainly it can just pick an algorithm between these 2 of like, you're off in Never Never Land, I don't care what you do. But yes, when you need to know the overlaps, if overlap says true, you probably want to know, is it left or is it the same? And then is it lefty overlappy or righty overlappy, because that's going to change what you're going to do next.
Right overlappy and left overlappy. I like that.
Yeah. So I think that if overlaps returns false, you're in a good state. The moment it returns true, you're screwed. Unless we give you more information.
For a lot of
but
that's what I was arguing. That's like in majority of the code that I imagine people writing, they just want to know whether it overlaps. If it overlaps, they need to make a defensive copy, and if it doesn't overlap, they can call like base 64 encoding, like all the like transformation methods. You can just freely call them. The moment it overlaps, yes, you can be very clever about your algorithm, but most people would probably just do like a defensive copy. And I mean not defensive copy, like a stack alloc, transform to the stack alloc and then copy, so they don't have to worry about overriding data. The other all cases, maybe we just expose those ints and then tell people you are now dealing with some very complicated algorithm that you're trying to write. And
when we have the safety of the managed knowledge that you're talking about different arrays, I don't know that it makes sense to talk about how far apart they are.
I don't think so.
But once if it's a pointer, then there's really nothing you could do. But
I just don't know how to design an API that like returns you, something different than those integers if they happen to be an array. I mean, that's an even more difficult API to use. And if they are managed array, yes, the integers would be very far from each other, and your higher level algorithm will tell you, don't worry, they are different memory locations. You can just do transformation. Don't worry about
one answer is you ask, try get deltas or whatever, or it's try get deltas and it returns false if they don't overlap, and then out's 0. Of like, I'm just not answering because no.
Well, I think that's what the out parameter would do for overlaps, right? Would return some like a 0 or something that does.
Well, like I don't know what to do with the element. I guess it can be negative.
Right. I forgot.
Maybe.
You have like the scenario is covered.
I see.
That's fair, because you know the length of both things, and so you just need to know how different their starts are.
Right.
So overlaps false, always outs 0, and if it's true, it outs the left distance, and you can compute the right distance if you need it. So then,
See, it says element offset is only valid if the check in question returns true. If it's false, like
yeah. So then, within, you could compute based off of overlaps outing the number. Because that would be if second dot length minus element offset is less than first dot length, then it's within. I think. I need to look at the subtraction formula.
So is it easy for you guys to understand, like, you're looking at the API that returns element offset, like, what this number is?
I think we probably want to rename it.
I don't
Because to me, like, this, like, those two integers, like, yeah, it needs, like, you need to see a drawing on the board, but after that, it's kind of, I think it's very clear, correct?
I think that would be the same
Right.
for this.
So it would be this number.
Really? Okay, go ahead.
It's this number with a boolean. And in this case, it would return. It would be false
Really?
0.
Is this number?
Yeah. And in this case, it's 9.
Right.
And true. Of this was 9, positive 9 off of this one.
I see.
This one is negative 4.
Okay, so it's basically how far the first element is.
Yes.
relative index of the start of the second span from the start of the
offset.
Yes, I would call it relative offset instead of element offset. Because you're not talking about elements, you're talking about where the start mark is.
Okay, so you basically can get this one, and then you can compute the offset of the end by just computing something with lengths.
You have the links and everything because you have a span.
Okay.
So.
Okay.
Well, I guess the reason that it said element is because it's not number bytes, right? It's number elements in between them.
So what about
So
within?
I just said relative offset.
So what about within? Is within also you can compute, correct?
Within would be is it a positive number, and if b.length plus this is less than a.length.
Okay, then we can just add those two overlap methods.
Yeah, so we don't need within either.
So what does within do? Does it say?
We don't need it.
What?
Someone can compute it given just the overlaps that returns the value.
The rationale for within was there are different optimization paths for the implementation of within, so it will make within faster. Like you can make within faster than overlaps. So if somebody only cares about within, they call this method and it'll be more performant.
So who cares only about within?
I know that Mark Gravel was writing some code about it. Again, it has to do with buffer pool management. That's a scenario where you want to return a span back and you want to know which buffer it goes into. That part, which buffer from your buffer pool goes into. So you just want to care about within. You keep calling it within quickly, and you'll get your response and you can return it.
Why would the overlap not work?
It's slower. It could be slower. The implementation would be different.
Performance optimization. I see.
So it's slower because you still have to check whether it's within afterwards?
Doesn't seem like it would be slower.
Yeah, like how can you write within faster than the same?
Finding the first pointer and then you're checking a link.
You still have to compare both sides of the buffer, right? Like, and I think if you have a buffer pool, you never have overlapping.
Yeah.
Like if you have a buffer pool, you don't run buffers that are overlapping, right? So like if it's overlapping, it's within, right? Like that statically.
Because you can't just say if b.length is less than a. Like if b.length is bigger than a.length, it's not or it's not nested, but you don't. But in order to determine true, you have to go through all the same work as overlaps. So the false path can be faster, but the true path can't.
No, because if one length is smaller than the other, you just have to do one check.
We had to do the link checks first, which is basically the same thing you would do after you did the overlap.
Yeah, it turns out if somebody wants to optimize their within that way, they can check the links first.
Okay, I've looked at the implementation.
It's not like there's magic that we can do because we have the span and the pointers and stuff. I can't think of any way that you can do it without a double bounce check. So
unless you presume the answer is already true in one of the cases, right? In which case you cheat.
So again, within has a fast false off of overlaps, but it can't get to true any faster.
Alright, so what about this? We add the first two methods, and then unless somebody provides a concrete justification why the second one is needed.
Yeah.
It seems like those two.
Do we need the first, or are we just happy without underscore for don't care?
About what?
Well, C# added out underscore for if there's an out parameter here and I don't care.
Oh.
So
what is it? You can call a method without.
Well, you have to write
underscore
overlaps A, B, out underscore. I don't care. If we think that that's ugly, which it kind of is.
Oh, you mean, do we need the overload that doesn't take the out parameter?
Yeah.
Yeah, I think because in a lot of cases we're just interested whether it overlaps or not. I mean, that's the majority of the cases.
Okay.
If it overlaps, I have a problem. If it doesn't, I just call methods.
Okay. I'm just I'm asking what our current framework design guideline rules are so that we're consistent. And then what do we think about the names of the parameters?
Oh.
We had first, second, and element offset. So I think element offset should be relative offset.
Either fine. Sounds good to me.
But, I mean, first and second single line.
Just wondering whether we should have relative start or beginning offset. So it's clear that it's basically relative to the beginning of the
Relative start?
Start offset. Relative start
relative
offset.
start.
Well, but it's an offset of either start or the second or the third. They all have the same offset.
I'm just trying to figure out how you convey that offset from the beginning.
So to me, the main difficulty is understanding: is it offset from first to second or from second to first? Maybe the name of the parameter should be just the equation.
It should be first minus second offset.
I think it, to me, logically, it feels like second minus first, and then this would be if I do first of I plus this value, I get the exact same value that I would get of second of I. Because it is the relative offset of their elements.
Can you show the sample code where they use overlaps?
So I think it's just relative offset.
Okay. Oh, they just throw, okay.
So, one additional thing, if we still are brainstorming the name of the parameter, I'm fine with relative offset. Why is case I and J not something that you can distinguish with this API?
What are I and J?
Can we look what I and J are? Why?
I think it's like
one of the sides are empty.
Oh, yes. When they are empty.
Well, if they don't overlap, we don't tell you if they don't overlap and the non-overlap is before or the non-overlap is after. I think that's because A and E, I think, were non-overlapping. Yeah. So when it doesn't overlap, we don't tell you what the relative positions are, especially if it's a managed array, that it can change. Well, if it's different managed arrays.
So why don't we always return, instead of when we return false, we still give you the offset?
Because I don't think we want to tell you how far apart two managed arrays are, if they're not the same array.
Why not?
Because what can you do with this information that's useful?
Well, for starters, it just removes a condition in your code, right? You just compare the numbers. Like, you don't care how far they're apart. What you care is about the not having to deal with the fact whether they are apart or overlapping. Right? You just write the condition. And then
but that's true in either case, because the boolean we return, the boolean means do they overlap or not, and the int we always return you.
I don't think we should be doing it. I think it's got to be within the same continuous managed memory block, which is the way.
Because the point is that it means nothing for non-overlapping. You can't make sense of it.
No, this would solve this problem.
But why do you need to know?
The ambiguity of the other case, right? Where
what is the case where you need to know?
That's a good question. I'm just saying. The only statement I made is it would solve this problem.
Yes.
I'm not sure whether the problem has a practical.
I believe the problem should not be solved.
You don't want to solve problem?
I do not want to solve the problem of telling people what the current layout of memory is when the whole point of .NET is you shouldn't know unless you're dealing with a very memory-specific thing. So
we don't expose the actual raw address on span.
Dangerous.
No, yeah.
Get
You can call some
adder
methods and.
There you go. So you want your thing, you can do that.
Okay, fine. That's actually I buy this argument. You can distinguish between I and J by basically pinning the thingies and
yeah, and then your answer is valid for as long as they're pinned.
Well, if you really want to be creative, you could just return -1 and +1 in that case, right? And then just indicate the relative order.
Yeah, I think.
No, because the offset.
I think if the
is both positive and negative.
If the two arrays are not if we have arrays on both and they're not reference equal, we just return false.
Look at these two. You're already exposing both negatives and positives on the range. So you can't use a -1, +1 from that.
I think if overlaps is false, relative offset is 0.
I'm saying you return false.
Oh, if you return false, I see.
Because then now you can use plus minus 1 because you just indicate relative order.
If somebody wants to complicatedly know the layout of memory of a reference object, they need to write unsafe, and if they're in a place where they can't, then they don't.
Right. So another argument for always returning the offset. We don't have like the parameter is called the relative offset. If they are not overlapping, they still have an offset. Why would we suddenly like return 0 from a parameter?
If they're not overlapping, the offset is meaningless. You can't pass it. You can't do A of I plus this
That
number.
offset is also in the size of T.
The only like for for try methods, we basically say that like if the method returns false, then we do like special things with other output out parameters. We don't do it for normal methods. This method is like, are the arrays overlapping? And by the way, here's an offset.
If you do that, you can't even necessarily get it in blocks of T. If the size of the elements are different sizes. That offset is in the size of increments of T.
No, both are of the T is the same. It has to be the same.
Yes, but
if you got two different unmanaged things, that delta may not even be a multiple of T.
Yes.
Between the starting points of two unrelated memory points. That offset may not even be.
They're not necessarily pointer aligned, and they can exceed max value.
Interestingly, I kind of think that it can be.
Not if T is
it can be true for even overlapping ones, unfortunately.
What? Not with the same T.
Yeah, with the same T.
How is that possible?
If you have a pointer,
you can basically cast a span of T, some large struct, to span of byte, slice by 1, and then do dangerous cast to span of the struct, correct?
Sure, but that's why it's called dangerous, because you're just...
What will we then return from this method?
it would be
given that you
delta
have
pointer
garbage
divided by size of T, so 0.
What are the semantics of, like... Yeah, I guess...
It's a question of what would the implementation be. If it's
You're already in a bad state for any of the span APIs.
I know that we are bad space. I'm just saying, like, we need to decide what to do in this case.
Right, so...
Regarding alignment, like one of the sessions what we will be throwing, for if there's misalignment between, like I think if you scroll up, the guy even mentions it.
I don't think you would throw from these APIs. That would be really bad.
The first, if second span does not match alignment of the first span, argument exception is thrown.
Why would you do that? Why would you just...
I think it's so that Christoph's question of
Don't call me if you're doing dangerous stuff, basically.
If you've intentionally shifted into stupid land, the question can't be answered anymore.
That's the point is you can't answer that question.
Yeah.
That's why you have to throw.
Because you're 1/10 of a value offset from the other one.
I'm pretty sure there are scenarios for like casting an array of ints to, span of ints to.
So why can't you answer the question?
So you have a span of integers.
It will not be a whole number if you compute the offset.
You know the second overload. The first one you can always answer, right? Because the only thing is that you have to say like, are they like, is the beginning of this and the
the Boolean you can always reliably return. The element offset is weird if they are misaligned.
Yes. So why would you throw from the first one then?
For consistency.
The person's probably calling the second one.
Like just don't do.
Just
like for consistency. It basically tells people don't do these things that Jeremy called stupid land or something. Like you cast a span of, some struct to span of byte, then you offset by 1 byte, and then you cast it back to span of.
So the reason why I don't like that is like it means you have to be very careful like how you slice. And if the only thing you care about is like are they overlapping?
If you took a span of T, where T is a multi-byte thing, and then you turn it to a span of byte to intentionally misalign, I don't care what this does.
Not. You don't have to be careful when you slice. You have to be careful when you cast from span of bytes to span of something larger, and that's why the method is called dangerous cast. It's actually it has it in the name.
Do we have a dangerous cast? Or you mean you just create you can create a span out of a ref object?
No. To cast from span of byte to span of something else.
Non-portable cast?
Yeah, non-portable. Sorry. Oh. Yeah, it's not called dangerous. It's called non-portable.
Sorry. So the only case with this way throw if you ever did
upcast, kind of up in a sense that it casts to something larger.
So you move a struct into bytes. You move by a non-multiple of the size of the struct, and you turn it back into a span of that struct. The relative offset just doesn't make sense. And as for whether or not they overlap, there's nothing sensible.
No. We could return the float from the relative offset.
Yeah, we could.
We need a rational number, actually. Float would not give you the right answer all the time.
I think that's fine.
But anyway, so the reason that I don't think that we would want false to try returning thing, aside from misalignment, is in a 64-bit process, 2 arrays can be more than max value apart.
Well, you could return it long, right? If you really cared about that scenario. But I think Wes's argument is stronger because there is no number you can return in some cases if they're not overlapping.
Really?
Yeah, because there could be 2 bytes apart, and you're
not even intentionally trying to do anything harm. They just had 2 different arrays, and where did GC put them? It's not aligned.
Well, in practice, though, can you get it? It will always be pointer aligned. Probably.
So I just think that we would just say that if we're returning false,
okay, it's fine. It's fine. If we ever run into limitation here, we can do something.
Indeed.
So, this is the last time we can touch the API.
Relative rename.
So what's the name of this guy? Happy with element offset, relative offset? I don't care, honestly. Neither one of those makes sense.
Isn't offset relative, but isn't that the definition of offset?
Okay, let's call it just offset.
Non-relative offset?
We can go with offset.
But the point was to make element rather than bytes, because offset would mean the number of bytes being offset.
Yeah, but we got rid of the word.
Oh, I see. This is a good point.
But
the parameter was called element offset, so it's clear that it's in T is the currency,
right.
Not byte. We could call it byte offset, and then we could return it all the time.
Sorry, what was the answer earlier about what it means in terms of which is first?
Yeah. Second minus first.
What?
Second
minus first. Okay.
That's not how the API is written. When you do a subtraction, you do first minus second.
All right, whatever.
You read the docs. It says second minus first.
But here's a fun one. We decided not to have it, but how would you read the within method?
How would you implement it?
No, how would you read it? What would it mean? If you say first dot within second.
Mm-hmm.
So what does it mean? Is it logically equivalent to first contains second?
No, the other way.
That's the other way around, right? Which is, I think, if you think about it, not a very logical way to ask the question. It seems backwards.
Really?
Why?
Because almost all APIs we have go the other way around. You ask the larger one, but it contains the smaller one, not the other way around, usually.
Yes, but this isn't.
So that's because these guys contains, right? The name change caused the flip.
Exactly, but that's what I'm saying. The only reason why we did the name change was to reflect the fact that we don't look at content.
We do have is subset.
But you still do logically the same check. You ask whether this range is within that range, right?
Well, I think set is subset of.
Yeah,
what you're asking is the thing on the left smaller.
That's different.
I think that's
fair.
Compares elements.
I'm just saying that.
Also, there's 3 people that ever called this API. 2 two of them were tested for that feature.
And the other person is just weird one. Alright, like, I don't know. Are we happy with that then?
Which thing do comparers return?
Sorry? Compares?
Is comparer of t b minus a or a minus b?
If first is smaller than the second, it's -1.
I have to look up the number.
So that's a minus b. Oh. Yeah, because if a is 0 and b is 2, then it would be negative.
Oh.
Okay.
Probably we dropped off. Of course we dropped him off again.
Yeah, the answer is you try it once, it returns the wrong sign, your program crashes, you flip it, and then you understand what it does.
We don't crash that easily. Your program just does something else.
Well, if you have good tests, then your tests immediately fail. Like if you the overlap case correctly.
So do we have this for memory of T? The overlaps methods?
Yeah, that span overlap.
It's in the sequence.
In fact, implementing it on memory any other way would be so tricky that we wouldn't be able to do it in any other way.
Because between the time you asked the two addresses, they could have changed?
No, because memory can be like many different things, including an abstraction that gives you like some numbers that don't even exist. I don't know. Memory is an abstraction. It could not be even in memory.
So did anybody follow this one here?
So this one I can speak to. This came about because Tim had put up a PR where he was relying on memory's constructor to validate the array offset and count arguments, which makes sense, except they're named differently. So if they fail validation, the exception that gets thrown contained the wrong parameter names. So I had suggested he should still be validating at the call site the inputs to throw the right exceptions, but then we're duplicating checks, which is unfortunate. So this came about as well. Should we rename the arguments in memory's constructor from array start and length to be array offset and count to match sort of the predominant arguments used in similar situations elsewhere? Or should we have a constructor or factory that doesn't do any validation and you do the validation yourself so that it still just happens once? Or should we not care and we just do the double validation? Or should we not care and it doesn't matter what the argument names are, you get an exception and you may not be able to correlate it based on the parameter name?
Why we do double checking to get the parameter names correctly?
What was the question, Emo?
Are you saying we're duplicating checks purely to get the string for the parameter name correctly in the exception message?
Yep.
Yeah. Or if we rename all the parameters to be the same, then it just happens to look right.
Yeah, that seems like an almost no-brainer to fix that.
No. We cannot rename the parameter.
Why not?
Because we would have a parameter called count, and the property we would on span would be called count. So now it's not as the array where the property is called length. Like
that's why you would burn a cycle on the CPU every single time you construct that guy?
No, I would, like, if we want to solve this problem. So one I think solution is to just span this problem. Like, yes, you have to do the check twice, and because you're adapting like some existing code to new code, you have some inefficiencies. The second one is I kind of like the proposal to add a method to create span without validating, especially for arrays, because it's not like memory unsafe. I would just not put it directly on span. I would put it in some, like, bury it somewhere else.
That's where it is. It's in interop services.
Oh. So in interop services we add a class called span? No, let's not do that. But, okay, I didn't notice that. Yeah, it is buried. I would just call the type something else.
That's a bad name, though.
Which one?
Something else.
Oh, I see.
It's called Marshall.
Yeah, Marshall may be in the right. Yeah, I would not burn the name span, because at some point maybe we want a span type to avoid the generic.
So, like, how does it look like? How do you use this API to avoid the double checking?
You call this and you don't get any checks.
No, I mean like the full code. Like I mean.
What, full code for.
So if you look at the beginning of any method today that takes any stream, read, async, or anything, it takes a byte array and an offset and a count. There's like 4 checks that happen up front where it says, is the array equal null, throw argument null exception. If offset less than 0, throw argument out of range exception, etc. And then it says, new memory, passing in those same arguments. And today, new memory does those exact same, very similar checks. So if we were to go down this path of having this dangerous method, you'd do all those same checks, and then instead of calling memories constructor, you'd call dangerous create.
So here's my question. If you do these checks already, then why would you get the exception from when you do new memory, when you call the constructor?
You're not going to get exceptions, but you're going to do the checks again.
Yeah, you pay the double check.
Yeah.
So Steve, do you believe that double checking is a significant performance problem?
I doubt it. That's what my suggestion was to Tim, was to just add the checks we want.
I mean, we had a similar situation in an immutable array where we basically decided that the indexer doesn't validate the argument. We just index into the array.
We have double checks all over the place in the stream too. When you call an envelopes, public envelopes.
True, but those are not necessarily marvels of efficiency of today, right? Like, I mean, immutable array was designed for perf, and we said, yeah, when you get a slightly different exception, only we get index out of range, and then the other, I think you get the same exception by default. What was the thing? I think the stack trace was not the one we were happy with, but we said, screw it, like, it's better to do it this way, to avoid the double checking. But honestly, indexing, you do way more than you do, bulk operations over stream. So, I mean, hopefully those things are like...
I wonder though if there's other scenarios for dangerous create, that the ones that we don't have the array and offset stuff being checked in our other APIs. Like instead of using span, you use dangerous create. Because we already are sure that the index and length are already valid.
Yeah, but there are probably some other scenarios. It's a common problem that we do, double and triple and quadruple checking. The question I would have is like, in comparison to the cost, like how often do you create spans?
For memory, you create a lot, right?
That the cost of these checks would matter. I don't know.
So why the heck did we put dangerous create on span of t?
That one is a bit different.
Well, why did we put it there, as opposed to somewhere else in interrupt service?
I think there was a issue files to move it. Isn't this the method that is hidden so people cannot find it?
It's just fucked with the... It's not... There's no actually...
I thought there was an issue to move it to Marshall or interrupt services.
I don't know.
Oh, interesting.
I think that someone would just say when the method says dangerous, you shouldn't call it.
I'd open an issue to move everything that was dangerous, whatever, to some span marshal or memory marshal class, and there's an open issue for that.
Yeah, do you remember we had a discussion about this, correct? And I think we decided to move that.
Okay, in that case, if that's the case...
Especially that, like, in the future, I hope that we're gonna get syntax for pinning spans in the language. And then, like, it would be nice to not have these methods there, because majority of the scenarios you won't have to do it. You just pin.
So what would we call the type? Because it seems to me like having 2 types seems very weird.
It would be the base rotate.
Dangerous memory extensions. We have memory extensions and dangerous memory extensions. We move all these methods there, dangerous memory extensions in system runtime, whatever, interrupt services or... Steve, what are your thoughts on this?
I mean, my initial inclination, just looking at these specific create methods, is we probably don't need them, and we just, and if we find that there actually is a measurable cost to having the extra checks, then we can add something later. But right now, I've yet to see evidence that there is. I mean, part of me doesn't want to burn any extra CPU for any reason, but At the same time, like I doubt it's really measurable in these cases.
Yeah, but that's but I would say we could decide not to do these two methods, but like if you want to move the existing one, it's just to come up with a name for that guy.
Sure. Well, so if for that separate issue, we might want to go look at it because we already had an issue that we talked about where we put these things. We talked about having some sort of span marshal or memory marshal, or even just adding them to the existing marshal class, and I would be fine putting them there. The idea there was that marshal itself is sort of already thought of as an unsafe thing or a dangerous thing.
Dangerous is something that much dangerous.
I think it's number 23879.
Oh.
I think it's the support casting read-only memory to memory of T. That one.
It's just me, but like I almost want to see them as one type, not two types.
Yeah, it should be just one type.
But then you kind of want to have them.
Yeah, memory marshal. Just like the other type we call memory extensions. This one we would call memory marshal or dangerous memory extensions. They wouldn't be extensions, correct?
No.
So,
well, that's the thing, right? Like if you get away with them having. Well, I guess it depends what you do with them. Like those are taking those guys as input, so they could go either way. But like the dangerous ones that I've just looked at earlier, they were factories, right? So you don't know what they're. You don't know whether they returned this one or that one. Right?
sorry?
Right, so the only problem that you have basically to making it one type is you need to be able to tell whether you want to get a memory or you want to get a span out of them, right?
Well, instead of being called span of t.dangerous create, it'd be called memory marshal.create span or something like that.
Exactly. So you would have to either specify the name and the method or something, right? Make sure you have a unique signature. Which would work. Like I wouldn't do the dangerous span extensions, for example, because then it's like dangerous span extensions dot dangerous something, right?
Yeah, and if they are dangerous, there shouldn't be extensions.
Yes.
So the only thing, like, but that's a separate issue. Like, if we have a language support that is specific to span, they can call whatever method to pin things. They probably will want to have some convention how the method works, and I don't know if they like some other static method in another type, because it's difficult. Like, how do you tie them together? How do you know? Instance method is very convenient. We just have a name, and when you call fixed, this method,
Right.
Which is in general hidden from the.
which we would hide, or it's even today hidden, or I don't remember. We hid one, but not the other, correct?
I think so.
We hid some dangerous APIs, but not all.
So Ben was saying that for every async read would be 8 to 10 checks. So there aren't issue with checking. It's not one check. Issue with checking is it's 4 to 5 checks that are done twice. So it's 8 to 10 in the async case.
And what's the cost of async read?
Yeah, that's the thing, right? Like, once you go down that path, maybe it doesn't count. Like, it doesn't matter, right? Let me put it this way. I think we can decide not to do them for now. We have a pattern for what we would do that we would have. What was it again? Memory
Marshall.
Memory Marshall, and that's what we would put the other guys. So do we have a tracking issue now? Like I think this one is still open.
Yeah. What is the status of this one? Why is it not showing on the list?
It's already been approved.
Oh. Okay.
Buffers Marshall.
Buffers Marshall came up with that.
Yeah. Let's rename it. Let's approve memory Marshall. Because we already said that like we're gonna have like if we have those grab bags in this assembly, we use the memory as a prefix.
Just change your mind.
So the moment we have memory,
At least we're tracking it perfectly.
so the moment we have this method, I kind of don't mind these constructors that don't do the checks, especially that they take arrays. So I assume that checks will happen at some point anyway, correct?
Well, the caller's side somewhere, yeah.
Unless they don't actually happen. Yeah, the checks may not be, like, if we don't do the checks in the constructor, they may not ever happen. Correct? Because the moment an array is put in a span, it's a byref. We need to make sure that the checks at least happen at some point lazily, and not just like if you call this dangerous method, now you kind of can write and read all over the memory.
Why not? I mean, literally called an API called dangerous.
Not that dangerous. I mean, dangerous means like,
But we already have the dangerous create, right, with the whole object, ref object.
Yeah, exactly. It's dangerous. If you
Are they really that dangerous?
yeah,
There's no checks,
you write arbitrary memory. Yeah. You take an object, you convert it to a span, and then you start writing to it. Like, I mean, how is that safe?
Well, with that one.
But don't the checks would happen as part of accessing the span property on memory, right? Like when you go to get a span, it'll do its own checks in the span constructor.
From memory, yes, but not just if you use a span.
Yes. So, look, if you have an object, and you also have length, and the dangerous create that we have today, you can pass arbitrary length, correct?
Yes.
We don't do any validation of like what the object is. Because the thing is, with this API, you can pass an array, and it's empty, and you can pass length 10,000.
Yes.
Now you can kind of write over some memory that is not even part of the array.
Yeah, I can call dangerous create, pass in a string, pass an offset 10 million, and then write to that.
So that's the question, whether this dangerous create object actually validates it may actually validate the length.
I'm inclined to say it doesn't.
Yeah, probably, but I don't know.
I would be very shocked. Like, how would you even do this in general case? Do you special case every single type? I mean, you accept an object. Like, you would have to know it's a string to even do any sort of bounds validation. Yeah,
We might.
Let me bet $10 right here. I'm pretty sure we just.
What are the odds that you're giving? Because I'm not willing to bet $10 for your $10. I'm
Looking
willing
at
to
that
bet
signature,
I bet $1,
how is that?
but you give me 10. If I
I don't
win.
know how that works.
No, that's how betting works. The odds are not always 1-to-1.
Yeah, it doesn't do any checks. The only check it does is length is greater than 0. Greater than or equal to.
Then
Which is debug. Debug us, right? Not real.
Let's just say you owe me a scotch. It works.
just a scotch? Which one?
Yeah, no bourbon bullshit. That one does not go well with me. Alright, so in that case, I don't know. I think we have a problem. Okay, now what do we do with this one? We punt this guy for now and say if we would ever do it, we would add it to the other guy.
Well, if we already have dangerous create from object that takes arbitrary.
So like
Thanks.
this one seems to me like a case of premature optimization in the sense like we're not convinced the checks harm. Adding the APIs seems like the only reason you would have them right now is for those cases, which we don't believe are not.
This one or the other ones? Because this one is not just a optimization.
So what is this one for then? This is
sorry, I meant the dangerous create that already exists.
No, the other one. No.
Yeah.
So there's these guys here, which
Yeah.
you already approved, right?
There's also dangerous create that we already have, and it's not currently on memory.
I think this is the whole discussion on what to do with them, right? So they went through like 5 iterations on this one.
Yeah. So we move those, okay, to Marshall. Now you're saying that the new methods that are proposed, it's premature optimization. Ben is saying that it's a lot of checks. Ben, is it relative
You can see the code, I think.
to the cost of those methods, or it's a lot of checks kind of in the abstract?
Let me put it this way.
Like, how expensive are the methods, the async methods that you would just call subsequently?
So guys, I have a hard stop in 12 minutes because I don't want to battery, so you better make a decision now.
Is Ben online?
He is online.
Ask him how expensive are the async methods that he called.
Well, you just asked him, right? Because we're live.
I don't know what kind of delay you have.
There's some delay. But Ben is thinking fast, so that offsets that again.
No, he's counting the instructions while executing the code in his head.
He's saying like one of the common cases is you complete synchronously, right? In which case you are actually quite fast.
Well, okay, let me say I don't mind adding. Like, since we have this Marshall type, I don't mind adding. And we already have a method called dangerous create, and it creates it's even probably more dangerous now that we discovered it doesn't do any checks.
You're saying it should do checks?
Yeah, but at least this one takes an array. So, like, potentially at some point, like, we have all the information. We are not doing checks. The other one is, like, taking...
No, but if you add new APIs that do checks, then you defeat the point. The whole feature of this thing is to not do checks. Because they are
equally dangerous. So, by not adding them, we are not buying much. I can actually...
So I'm not confused what you're saying. Are you saying we should have these methods?
I don't mind having them.
And you don't mind if they don't check? Correct. Good. Because that's
as long as they are on Marshall type hidden in the interop services.
We are in agreement.
So, a bit of a side question. Can you use the existing dangerous create to do exactly this? You just need to know the ref. You can pass array as the object. And the ref offset, you can compute it using unsafe API, correct? Offset to the first element from the array. And then you basically can do this using the existing API. So these new ones are just helpful.
Yeah, it's only for span, right?
Okay, so we only have it for span. Okay. Mm-hmm.
We only did half of what we said all today.
But we still have 10 minutes.
Yeah, until my recording shuts down.
The proposal starts with a rationale. What is the proposal?
There's proposal. Yeah. The example in GitHub says rationale and usage first, then propose API, and I don't understand why.
Well, because usually, like, the rationale is I need a feature X, and there's like 500 APIs. You start with the 500 APIs, I'm like, what the fuck do you want to achieve in the first place?
So we need to add conversion APIs. Oh, basically,
This will be
create
discussed
read-only
earlier.
memory from memory.